Hey everyone, and welcome back to another video. In today's video, we're going to determine the number of lone pairs in the marked atoms of the following molecular structures. Before we look at these structures, let's remember that it's very simple to identify the number of lone pairs for basic atoms such as nitrogen and oxygen, because these are the atoms that we're looking at. Right? So specifically, whenever we want to do that, we have to remember the octet rule. The octet rule states that your atom must have 8 electrons around it to satisfy the octet rule. Specifically, in order to find the number of lone pairs, and as long as the octet rule is satisfied, we are going to use the following formula to identify the number of lone pairs on each of our atom. We are going to essentially subtract 4 minus the number of bonds, and this will be equal to the number of lone pairs of electrons, right? The reason why we're taking 4 is because if you recall, every bond has 2 electrons in it, right? Every covalent bond. So if we have 4 bonds with 2 electrons in each of them, that corresponds to 8 electrons total. So if we subtract the number of bonds, we will end up with the number of lone pairs needed to satisfy the octet rule. Starting with A, we can apply that rule. We have 4 minus the number of bonds here bonded to that nitrogen is 1, 2, 3, 4, right? 4 minus 4 bonds, that gives us 0 lone pairs, okay? So we can say that the number of lone pairs here for A is 0. For B, we have 4 minus the number of bonds around that nitrogen, 1, 2, 3. So 4 minus 3, that gives us 1 lone pair on that nitrogen. So we can add that lone pair, and we can double check if now the octet rule is satisfied. 1, 2, 3, 4, 5, 6, 7, 8 electrons around that nitrogen. So the octet rule is satisfied with a lone pair, with 1 lone pair. Now moving on to C, we would have 4 minus, and we see 1, 2 bonds, right? So a total of 2 bonds. The difference between 4 and 2 gives us 2. So the number of lone pairs would be 2. And for D, we would take 4 minus, how many bonds do we see? This oxygen is only bonded to carbon, so that's only 1 bond. The difference between 4 and 1 is 3. So the number of lone pairs would be 3. We can also add them. For C, we would have 2 lone pairs. For D, we would have 3 lone pairs. We can also check if we are right. 2 bonds, that's 4 electrons. 4 more from lone pairs, that's 8. The octet rule is satisfied. And for the last one, 6 electrons from lone pairs plus 2 in the covalent bond, that's 8. So the octet rule is satisfied in each case. So our answers are, for A, there are no lone pair electrons. For B, there's 1 lone pair of electrons. For C, there are 2 lone pairs of electrons. And D, there are 3 lone pairs of electrons. This corresponds to the answer C in the multiple choice. Thank you for watching.